Hello there, mathletes. Welcome back to Math Jamboree. In this video, we have another AP Precalculus type of a question from the topic of polynomial functions and complex zeros. Let's solve it together. The polynomial function p of x is given as x plus 4 times x squared minus x minus 5. Which of the following describes the zeros of p? A. P has exactly two distinct real zeros. B. P has exactly three distinct real zeros. And C. P has exactly one distinct real zero and no non-real zeros. D. P has exactly one distinct real zero and two non-real zeros. To find the zeros of a polynomial, we will make the factors equal 0 and solve for x. So there are two factors given. When you multiply these two, you get the polynomial function. That's why they are called factors. And we will make them equal 0. X plus 4 equals 0. And we have x squared minus x minus 5 equals 0. So when you're solving, you're going to take away 4 from both sides on this one. And x will becomes negative 4. On the right side, can I factor this? And x, but when you multiply what numbers? 5. What factors of 5 when you multiply, that gives you 5, but when you add them, you're supposed to get negative 1. The factors of 5 are 5 and 1, but when I add it, I don't get negative 1, so I cannot use 5 and 1. In this case, we're going to use then quadratic formula. So remember, in the form of ax squared plus bx plus c equals 0, the number from the in front of the x squared is the a. So based on this and our equation, the a value will be the number in front of the x squared, which is positive 1. Rb is negative 1. And c is negative 5. So we're going to use the quadratic formula to solve this equation. The quadratic formula is again x equals negative b plus or minus square root of b squared minus 4ac divided by 2a. Let's do the substitution now for this quadratic equation. So b is negative 1, so negative 1 plus or minus square root of b squared is 1 minus 4 times a is positive 1 and c is negative 5 divided by 2 times 1. So we will simplify this. This becomes positive 1, right? Because negative is positive. And inside of the square root, let's take a look at it. Negative 4 times negative 5 becomes positive 20. And there's plus in front of it. It becomes positive 21 over 2. So if I will write the roots, x1 becomes negative 1. I will just use positive 1 for this. Root 21 over 2. And the x2 will becomes negative 1 minus root 21 over 2. So as you can see, if I will write the factor,